In this episode, we're going to build a beginner-friendly picture of how monitoring systems collect data, because a lot of troubleshooting and alert quality depends on understanding where the numbers and events actually come from. It is easy to think monitoring is just graphs on a dashboard, but those graphs are built from collection methods that have strengths, blind spots, and failure modes of their own. When you understand the collection method, you can ask better questions like whether the data is fresh, whether it is complete, and whether it reflects what the user experiences or just what a device is willing to report. We'll focus on Simple Network Management Protocol, SNMP, which is common in network and infrastructure monitoring, and we'll connect it to traps and management information base, MIB, structures that make the data interpretable. We'll also clarify the difference between agent-based and agentless collection, because that design choice changes how you deploy monitoring and how you troubleshoot missing or misleading signals. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful first idea is that monitoring data usually comes in two broad flavors: metrics and events. Metrics are measurements taken over time, like a counter, a gauge, or a rate, and they are often collected on a schedule. Events are discrete messages that something happened, like a link changed state or a device rebooted, and they may arrive asynchronously. A mature monitoring strategy often combines both, because metrics show trends and baselines, while events provide context and immediate signals. The collection method determines how you receive metrics and events, and it can also determine how quickly you learn about changes. For example, if you only collect metrics every few minutes, you might miss short spikes, while if you rely only on events, you might miss slow degradation that never triggers a clear event. Keeping this metrics versus events split in mind will help you understand where SNMP polling fits and where SNMP traps fit. It also helps you interpret alerting, because many alerts are triggered by thresholds on metrics, while others are triggered by events. Simple Network Management Protocol, SNMP, is a standard way for a monitoring system to ask a device for information or to receive notifications from it. Even if you never configure it directly, you will encounter it in network monitoring discussions because it is widely supported by switches, routers, firewalls, printers, storage appliances, and many servers. The mental model is that a monitoring system acts like a manager that wants to know what is going on, and the device acts like an agent that can report certain data. The monitoring system can request specific values, and the device can respond with the current state of those values. This makes SNMP a kind of structured question-and-answer protocol for device health and performance. It is not magic, though, because a device can only report what it exposes, and the monitoring system can only interpret what it understands. That is why the structure behind the values matters as much as the transport protocol itself. Most SNMP metric collection is based on polling, which means the monitoring system asks for values at a regular interval. Polling has a simple advantage. It is predictable. You know when you asked, you know what you received, and you can spot gaps when a device stops responding. Polling also produces time series data naturally, because you are sampling the device over time. The trade-off is that polling creates load, both on the monitoring system and on the network and devices, especially if you poll many devices frequently. Polling also introduces resolution limits. If you poll every 5 minutes, you will not capture a 1-minute spike with high accuracy. For beginners, the most important takeaway is that the polling interval influences what the graphs mean. A graph point is not continuous truth. It is a sample at a moment, and samples can miss details. Understanding that keeps you from overreacting to small fluctuations or missing important trends in events. SNMP traps exist to address part of that limitation, because a trap is an unsolicited message sent by the device to the monitoring system to report that something happened. Instead of the manager asking, the device speaks up when a relevant condition occurs. This can make detection faster, because you do not have to wait for the next poll to discover a link went down or a device restarted. Traps can also reduce polling load because some information can be delivered as events rather than being checked constantly. However, traps have their own challenges. Because they are delivered asynchronously, you need reliable delivery paths, and you need to consider what happens if the monitoring system is unreachable when the trap is sent. In many designs, traps are treated as helpful signals, but not the only source of truth, because a missed trap could mean a missed incident. A safe beginner mindset is to treat traps as fast notifications, and polling as the steady heartbeat that confirms ongoing state. To make any of this useful, the monitoring system and the device need to agree on what is being measured and how it is identified. This is where the Management Information Base, MIB, comes in. A MIB is a structured description of the data objects a device can expose via SNMP. Each object has an identifier, and that identifier points to a specific type of value, such as an interface counter, device temperature, or system uptime. The structure is important because it turns raw numbers into meaning. Without the MIB definitions, you might retrieve a value but not know what it represents or how to interpret it. The MIB also helps the monitoring system map data from many devices into consistent categories, even though different vendors may implement different sets of objects. For a beginner, it is enough to think of a MIB as a dictionary of measurable things a device knows how to report, with a standardized naming and organization scheme. MIB structure also explains why you sometimes see monitoring tools that can discover metrics automatically. If the tool has access to the right MIB definitions and the device supports them, the tool can query the device for available objects and then decide what to collect. This can make setup faster, but it can also create the temptation to collect everything, which increases noise and load. A good monitoring design is selective. You choose the indicators that matter for health and for troubleshooting. Another reason MIB concepts matter is that different device models may expose different sets of objects, so the same monitoring template might work perfectly on one device and only partially on another. When you see missing graphs or strange gaps, it is often not that SNMP is broken. It may be that the device does not expose the object you expected, or that the monitoring system is using a MIB definition that does not match the device. Understanding that keeps you from chasing the wrong problem. Now let's connect SNMP to the broader question of agent-based versus agentless collection, because SNMP is often considered an agentless approach from the monitoring system's perspective. Agent-based collection means you install a piece of software on the system you want to monitor, and that software gathers local data and reports it to the monitoring platform. Agentless collection means the monitoring system gathers data without installing software on the target, often by querying built-in interfaces like SNMP or by using standard network protocols to retrieve information. The big operational difference is deployment control. Agent-based monitoring can provide richer, more detailed data, especially for application-level signals, because the agent can access the system internally. Agentless monitoring can be easier to deploy broadly because you do not have to manage software on every target, but it may provide less detail or depend on network reachability and protocol support. Agent-based approaches shine when you need deep visibility into a system's internals, such as process-level performance, detailed disk behavior, or application-specific metrics. Because the agent runs locally, it can measure what is happening even if the network path to the monitoring system is degraded, and then report later when connectivity returns. Agents can also normalize and enrich data before sending it, which can reduce confusion in dashboards. The trade-off is that agents must be installed, updated, and secured, and that becomes an operational responsibility. From a security angle, an agent is additional software that could have vulnerabilities, and it often requires permissions that must be managed carefully. In regulated environments, installing agents can require approvals, and in lockdown systems, it may not be possible at all. So agent-based monitoring is powerful, but it is not free, and it needs governance like any other deployed component. Agentless approaches shine when you need broad coverage quickly and you want to reduce the footprint on target systems. Network devices are a classic example, because you may not be able to install agents on a switch or router, but you can often query SNMP data that the device already provides. Agentless collection can also be simpler to manage at scale because you centralize complexity in the monitoring platform rather than distributing it across many hosts. The trade-off is that agentless collection can be limited by what the target exposes and by how reachable it is. If the network path is unstable, agentless metrics may appear to drop out, and you may struggle to distinguish between the target being unhealthy and the monitoring path being unhealthy. This is a subtle but important point. Monitoring is itself a distributed system, and failures in the monitoring path can look like failures in the target. A mature monitoring strategy includes checks that help you interpret which part is actually failing. This is where traps and polling can complement each other even in agentless designs. Polling provides a steady rhythm that can reveal gaps in communication and long-term trends. Traps provide rapid notification of certain events that might be too slow to detect by polling alone. If a device sends a trap that a link is down, you can learn immediately, and then polling can confirm the ongoing state and collect counters that help you understand the impact. If you miss a trap due to a delivery issue, polling can still show you that the interface is down and that traffic counters stop changing. From a beginner perspective, the important lesson is that collection methods overlap to reduce blind spots. Relying on one method exclusively can make your monitoring brittle. When you combine methods thoughtfully, you get faster detection and better confirmation. To close, the big picture is that monitoring data does not appear by accident. It is collected through specific mechanisms that shape what you can see and how trustworthy it is. Simple Network Management Protocol, SNMP, is a common agentless protocol for collecting device metrics and for receiving event notifications through traps. Management Information Base, MIB, definitions provide the map that turns raw values into meaningful indicators. Agent-based collection installs software on targets to gather rich internal data, while agentless collection queries targets remotely using built-in interfaces, trading depth for ease of deployment and centralized control. A healthy monitoring design respects these trade-offs, uses the right method for the right target, and combines polling and event signals so you can detect issues quickly without losing reliability when something is missed. When you understand these concepts, you can interpret monitoring data with more confidence and diagnose collection problems without guessing, which is exactly the kind of conceptual mastery that supports both real-world ops work and Linux plus exam thinking.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.